Hello guys, today we are going to talk about our project 3 of our database class CS532. My teammate Anila will be giving you the introduction. Go ahead, Anila.
Yeah. Uh, the growth of data has intensified dramatically uh, over the past decade, and some of the fundamental characteristics of the relational database are incompatible with the big data demands. The problem with the RDBMS is it's not, we can horizontally scale. It is limit to scaling up, that is vertical scaling. If we want more data to get stored, then we need to buy another server with more capacity, and that is more expensive. And relational database are not flexible. They are table based. They support only structured data. They won't support the varieties of data. Um, and it also require upfront schema definition, and changing schema at a later point of time is very expensive. Another point is that the performance. Data is stored across multiple tables, and we need to use join to retrieve the data. And join is expensive since it requires a lot of CPU and resources. So this led to the emergence of NoSQL. The NoSQL databases can handle the big data demands. It can do horizontal scaling, add up more servers, and support the growing demands. And it can handle data in different shapes and sizes, structured, semi-structured, or unstructured data. And defining data, no need to define data schema in advance. NoSQL is designed for big data. It supports horizontal scaling. More servers can be added, and data can be distributed across multiple servers. And these multiple servers, we can use commodity servers so that it will be cheap. And they do not require fixed schema like in relational databases. And it supports flexible data models. Based on the data model, NoSQL have different database types. One of them is document based. Another is key value. And there are wide column and graph model also. What is MongoDB? It's a NoSQL database, and it is document based, and it have flexible schema. It support structured and unstructured data types. It can horizontally scale up, and also it support auto sharding. It distribute data across multiple partitions, physical partitions. Due to that, it can support automatic load balancing. And no joins are required in MongoDB. So it is not expensive. Document databases store data in documents. Documents are a pairs of fields and values. Values can be strings, numbers, booleans, arrays, or object. Collection is group of documents. It is equivalent to table in a relational database. We used PyMongo for interacting with the MongoDB database from the Python. And these are some of the APIs we used. We used Mongo client for connecting to with the client. And for inserting document into the collection, we used insert one and insert many. Insert many can bulk insert. And for getting the document, we used find one and find. And rest of the slides will be explained by Gaurav.
Thank you, Anila. So now you have an understanding of what MongoDB is and what PyMongo is, and basically we had chosen PyMongo because Python was, the best way to build a command line interface for accessing MongoDB. So we'll just go over the code right now. I'll just explain the code a little bit so that you can see how I've written. So yeah, so we have a menu-driven approach, and you can see that all the 7 queries that we have here will be can be selected in this way. So I'll just show you an example for a few queries, like one of the graphs that we had developed, because many of them are very simple. Okay, I'll just show you a few of them. So maybe we'll go to the first one. One second. So yeah, we'll go into the first one and see the search by title. So let's say you can see here on the side. Let's say now I have to search a title. Let's say we want to look at the movie Avatar. So basically, I wanted to develop like a simple interface where you can just do basic searching through the entire document, and it will show you all the documents that were there. Like for example, the genre, the keywords that were related to this, the overview of the movie, and things like that. And also, I think one more interesting thing would be the if you wanted to see the relationship between the graphs and between a graph between revenue and budget. Uh, Once, okay, I think the graph is come here. Okay, here you can see that, or you can just see that there are many actually genres that were there. We just plotted the revenue against the budget. For example, let's look at this one in particular, adventure. You can see that for the amount of budget that you have set, the revenue is huge when it comes to adventure, but it's not the same for many of the other particular genres that we have. For example, maybe some of them are really really tiny, and our data set primarily shows the top 5,000 movies, so you might not have seen anywhere where the revenue is less than the budget. But I just wanted to see, for example, look at horror. Like it's really small, like not there are not many movies which are there in the top 5,000, and even though that you've gotten a good revenue on based on the budget, you can see it's nothing compared to the action genre. So that's there. And in case, what else can I show you? Maybe we can just I'll just show you how to search through a crew or a cast member. That one was really interesting. So actually, crew and cast is stored in a different database here. I mean, database since it's stored in a different collection. The main movie details are stored here in movie data, where you have, and everything related to the cast and everything related to the the other like who are the other crew members and other actors, and everything is stored in this collection. So we can just go through it. I'll just show you. um, search. So I just click that, and it'll ask you if you want to search through cast or through crew name. Let's say I want to choose through cast. Let's say I want to look at Johnny Depp. Johnny. You see, it returned all the movies that were there, like what all characters he has played, and it's gonna return all those details over here. So yeah, that's there, and also everything that I search here gets logged in searches. In case you want to see the topmost thing searches, like searches in another collection that we made here. So So here you can see that it stores all the details based on what all I have searched. So what this does is, in case in the future I want to look at most searched object, which is actually one of the queries that I've supported, where it shows the most searched thing, most searched title or the actor. You can just look through that. And what else is interesting here? I think we can see the sixth one, which will show you the most common hit combination in top 100 blockbuster movies. Like, I'll just show you that. Let's search through cast again, like Johnny Depp. So yeah, maybe this will probably show you in the top 100 movies who are all the top actors that are there and how many of them have been there. For example, Aaron Hamstein is there once in, like, he's there in one top 100 movie, and you can see that Bob Peterson was there in two of the top movies in top 100. So it's going to return the entire data set like this, and it's going to show you the count of number of top actors and how many times they were there in those top 100 movies. And well, we'll just go over one example of how you can enter a new movie database if you have. So we'll just enter a random movie, let's say database, and the budget would be $1,000 and revenue could be 3,000. So you can just say tagline could be anything. Time, let's say 10 minutes. Language English. En could be the movie. Vote average, let's say 100 people. Sorry, the vote average is something like 5.6. And vote count, let's say 100 people have voted. You can just write some of the keywords like code, study. You can just say this is fantasy. If you want to enter more movie, you can basically, if you want to enter multiple ones are supported like that, like you can keep on entering and it'll keep appending to the array, and at once it's going to insert everything. But if you don't want that, you can just press another button and it's showing the object ID of the inserted movie here. And yeah, I think these were the most other than the common ones, these were the more interesting ones that were there. I think we missed the fifth one here. I'll explain the fifth one. We can just go through the fifth one once. We can just it shows what the fifth one does is it's going to show us the like the best like under a director and an actor, what are the best possible, what's the highest grossing movie. For example, here we have Pirates of the Caribbean. Let's take a cast member. Let's say it's Johnny Depp here. Let's say a crew member. Let's say the director is somebody whose name I cannot pronounce properly, some Gore Verbinski. So let's paste that here and let's type the name, Johnny Depp. And let's say fantasy is the movie's genre. Here you can go. So it can show you that these two people have worked together in Dead Man's Pirates of Caribbean, the Dead Man's Chest, and that has a very high profit. And it's basically sorted with decreasing profit and the movie over here. So yeah, and I this most search attribute is also very interesting. You can just see that what all we have searched, other than in this one. Like for example, if you have done a normal search like title and one title and the title, or if you just search the crew name, or if you were searching for only the actor, it's going to return that. I'll just show you. So here you go. You see that before I was testing for the movie Avatar. So you see Avatar was searched five times, and the cast Johnny Depp was called 3 times. And you can see the John, when I was when I was searching to genre, it was called, I searched it once, and the runtime was 120. So even that is stored. So yeah, that was some of the outputs that we got. So let's go over the code ones, like some of the I'll just go through one of the function, maybe just for you to get an idea how we can actually develop, and why it's easier to write code and use MongoDB. For example, here I'm building an array based on this was the normal search where you could just say title equals to and then that movie's name. So you basically build the array over here. So it's first going to it's going to store it in an array. It's going to split it, and title is going to be the first one of the array, which is going to be the column name over here. The comparator will be here. Basically, the comparator will be, if it's in will be basically if you have multiple parameters. For example, if title equals to Tangled and Avatar, and you want to give multiple movie names, and there'll be a value array. So you can just use something like in and greater than, lesser than for budget. This is basically used for budgets and runtime and stuff like that. And you can see basically after you build the array, uh, for like it's different for each. For example, if it's budget, popularity, you don't exactly need the array because it's just a single value. But in keywords and all, you can use a value array. For genre, you can use value arrays. And for anything else, in case something doesn't fit here, this is the most generic form over here. And then it outputs this details that were there, and it's logging the search, whatever we have searched in the search DB. This one was that, and we could go through this one. Most searched is with the basic, one of the most basic one. I'm just using find, and I'm just like displaying the count of the number of rows and what all were there in that. Let's look at somewhere where I've used an aggregate. So somewhere over here, look, you can look at this. This is the director and genre relation. So this one, you basically take the input of the crew, and then you take the input of the actor, and then this is basically, here I was basically I've hard coded it, but we'll just run it again with removing this. You can just remove this and like that, and it's already there on the top, the title list, so you can just remove that. So yeah, if you can just, I'll just run this part again. So now if you, let's say you want to see the same thing, which was the oh, I think I've run it in the wrong way. I'll just run it, just run only the cell. Oops, I think there's some mistake here. Oh wait, I have to run from here to here, sorry. Yeah, so now you can see, I'll just have to enter the crew name again. So, and then you can just say, so you see it got the retrieval dead man's chest and all the profit and all these things over here. So now you can see how it works. So pipeline basically works like stages. So first, what is happening? First, it's gonna go through the main database, and it's gonna get the titles of whatever it's gonna get all the titles that were there with like you can start from here. See, so it's going to go through the movie.review collection, and then it's going to get with this crew name and with this cast name, what all movies are there. It's going to get the entire list. And then wherever this title is there in title list, now this is going to run through the movie 2. Movie 2 is basically the big database, which data set, sorry, which is having the this one basically, you can see here. So where's that? Yeah, this is the one where it has all the details like overview, runtime, and all this one. And then it's going to run through that, and it's going to retrieve each and every one, which is basically it's going to get each of these movies, and then it's going to then it's going to do projection. Projection is basically selecting, like it's going to display selective ones of them, like title equals to 1, so title will be displayed. And then profit is basically when you subtract your revenue from the budget, and it's going to do that like here. And then you can see it's going to sort by profit minus 1. This is basically sorting it in descending order. So yeah, that's about it. Like I've tried to explain some of the concepts of DB and just gone through the code a little so that you guys can understand and see what we were trying to do here with MongoDB and PyMongo and how they work with each other. And I think that's about it. Thank you.